talking. Hopefully this now, there we go. So on Canvas, you should now see under the assignments, what looks like another assignment, just the number that you got correct out of 26. So it's only graded out of 25. So if you got all 26 correct, you get 104 out of 100 points, right? Each question was worth 4 points. So 104 kind of was the percent would be like the highest possible grade you could have got, right? If you missed one question, you still would have gotten 100%, right? So that's kind of how that's being scored. So right now, I'll kind of change it. So they've kind of weighted what that second midterm should be. So kind of after class, or I guess during, you can kind of look to see kind of how that updates your current score. Now, when it comes to the quizzes, right, and when it comes to pack-back assignments, module readings, I dropped the 2 lowest quizzes, 2 lowest module readings, and your 4 lowest kind of class questions. Those aren't being dropped yet. So it's kind of worst case scenario. But what you can do is start to play around with, and we'll look more at this towards the end of the semester, since we'll have a little bit better idea of like what all the grades are going to look like as we get closer to that final exam. So I put up this kind of hypothetical grade tool. Yeah, that's what I called it. And you can play around with your own scores. This decides to download for us. There we go. Where let's say I got, these are my 2 scores on the midterm. Here's my weekly quiz grade, etc. I can even put in those CL points, which I'll mention those in a second. I can then kind of start to play around with what if I got, I don't know, what if I failed, right, that final, right? What would I need in order to kind of bump me up to right at that 80% mark, right? So I'm guessing a lot of you, Kelly, are kind of worried about getting a B in this class. So you can start to play around with this. Now, obviously, the current scores you see doesn't have those lowest scores drop. So as we get towards the end of the semester, I will kind of change it. So on Canvas, you can see what your grade is with those lowest drop. Right now, it's like if you continue to miss assignments or you do as poorly on some of those assignments throughout the rest of the semester. So kind of worst case scenario up to this point. For the CL points, there's only been 7 sessions, so the total possible points should be 1.75. There was some attendance, some of my CL leaders double counted that final week. They got confused with the way that the file was set up. So I think I should have all of those adjustments made and kind of re-uploaded those yesterday. So the CL points should be up to date and correct. The highest total possible right now is 1.75. We've got 4 more modules we're going to cover before the final. So 10, 11, 12, and 13. And we'll then have a week before finals week, which there will be an additional CL session. They'll basically just doing Q&A, probably over that practice exam, right? So there's still 5 CL sessions remaining, right? For 1.25 total points remaining, or a total, like I said at the beginning of the semester, of 3 total points by the end of the semester, okay? So right now, the highest total possible you could be earning should be 1.75, okay? And that isn't being factored into your grade, but it is shown to you on Canvas. I think I said before exam 1, I need to alter this. I'll edit this so that it says after exam 2, but kind of 1.75 being the total highest possible number of points. So I'll rename that so it makes a little bit more sense here after class, okay? Those should be up to date. You should have your exam 2 score up there. Other than that, we've got module 10, which we're starting on this week. So I put an announcement up before class. I was inundated with emails earlier. I was teaching all morning. I got back to my office. I don't know why Top Hat did a sync for all classes at like 11 something this morning. And for whatever reason, when it syncs it after the due date, that counts it as late. So I was showing everyone's as late. They should now all be corrected. So there was a question, the very last question also, just to kind of avoid confusion. I had a couple people reach out. It was supposed to be select all that apply, but the way that the feedback works, you could have selected like one of the 4 and it was still showing you like you got it correct or something weird. So just to kind of make sure that didn't cost anyone, I basically just threw that question out and only graded you out of the first grade. Okay. So those scores should be up to date. There should be no zeros kind of showing up as late assignments anymore. I've got added to my list now an email sent to Top Hat as to why they're syncing things at 11 a.m. this morning for no reason, because I was in class. But that's kind of where we're at before we jump into material. So any questions for me before we kind of dive into module 10 here today? All right. So CL sessions kind of back up and running this week. You've got your set of practice problems here. We'll start working through the slides today. I put up an Excel file, which we may or may not get to play around with a little bit today. But for sure on Thursday, I'll probably be using this file a little bit in class. Other than that, we'll kind of start out diving into this module 10, which is really the remainder of the semester is taking things we've already talked about and kind of getting like a total picture, right? We've looked a little bit at firms' costs, a little bit at consumer decision-making. How does it all kind of work together, okay? So we're going to start out with these markets that are pretty idealistic, but we do see markets come pretty close to having the traits, okay? So what we're going to call these markets are perfectly competitive markets. We're going to assume there's no barriers to entry, right? We're going to assume there's many firms and many buyers. So no one firm is going to have like, a majority of the sales in that industry. We're also going to have a homogeneous product, right? So this means that whatever the good that's being sold, every firm that's selling it, it really is like almost a perfect substitute, right? So really, it's like the most ideal world where everyone's selling the exact same product. And then kind of what goes hand in hand with point 2, although as we talk about different types of markets, we'll see how sometimes these don't have to be the same thing. But many firms, many buyers kind of leads us to this characteristic, which is that the firms and buyers in that market, have to be price takers. Whatever the price of that good is, that's what they have to sell for. Whatever the price of the good is, that's what the consumer is going to have to pay. Now, I know that like this isn't ideal in every single scenario, like even clothing, right? Clothing isn't completely homogeneous, right? If I'm thinking about, different clothing companies try to create a different demand for their product to kind of convince you that there aren't substitutes for their product. So here we're thinking about the good that I'll use today. And this is for me, the one that I think is probably has a little bit, some traits that maybe it's not perfectly competitive, but especially with a homogeneous product, we're going to use gasoline. Right? If you go to buy 87 unleaded gasoline, this is regulated so that if you buy it from Shell, Marathon, Speed, whatever it is, it's the exact same gas, right? It's literally regulated so that you have a homogeneous product. Also, we've got quite a few firms with no firms really having any power over the price, right? If you're driving down the road, there's 2 gas stations next to each other, right, in Bloomington, which are all in many corners. If one of them has a lower price, what are you going to do? Buy from them. So what is the other firm going to have to do to convince anyone to buy from them? Match the price of the other, right? So it is, there isn't really any one firm having control over this price, and firms and buyers are going to be what we call price takers, okay? Excuse me. So these are our characteristics. So we'll just kind of name a few that would kind of indicate that it's not a perfectly competitive market. So we'll dive deeper into what happens if this is the case in the next 3 weeks. But anytime someone like controls a scarce resource, so I think like De Beers Diamonds owns like 90% of the supply of diamonds in the world or something ridiculous like that. Legal restrictions. So anytime the government gives the rights to a company, I don't know, maybe Pfizer to make a vaccine or something like that, right? Legal restrictions that prevent other firms from entering that market. So one of the things that we said we needed to have is no barriers to entry. Firms can enter and exit this market freely, right? So no barriers from like legal restrictions. Also, existing firms aren't like keeping other firms out of this industry, so they're not kind of colluding to keeping out competitors. Natural monopolies, I think I've mentioned this a little bit, but it's like an electric company in Bloomington. There's only one, right? That's not going to be a perfectly competitive market. We have to have many firms, many buyers. No one firm or buyer has any influence over the price. We're all price takers. Okay? Questions up to this? We're just kind of painting the picture here. So we've got these ideal markets we're going to first try to understand, and then we're going to compare other types of markets like to this ideal, perfectly competitive market. Okay. So firms that are in perfectly competitive markets, what is a firm trying to do? So they're trying to choose an output level, a quantity of production that's going to result in the highest what? What do you think? What are firms trying to maximize? What kind of profits? Economic profits. So we're thinking about firms are trying to maximize economic profits by choosing a certain level of production or quantity. Okay? Now, when they choose that output level, when we talk about consumers, they did something as long as the marginal benefit was above the marginal cost. What do you think firms do? Same exact thing. However, the marginal benefit for a firm in a perfectly competitive market, and we've kind of already alluded to this in some previous material, but if I have to just charge whatever the price of the good is out there in the market, the marginal benefit to me from selling one more unit would simply be price, right? Whatever that equilibrium price is for that good. If I try to charge a different price, a higher price, no one's going to buy from me. There's tons of perfect substitutes. There's going to go buy from that. So the idea of like, I try to increase my gallon gas by 20 cents and the gas station right down the road, keeping their price the same. Well, I'm not going to sell anything. I have to charge whatever that competitive equilibrium price is. So here, for firms that are in these perfectly competitive markets, we know their marginal benefit. Their marginal benefit is their marginal revenue. Right? That's the benefit to the firm. How much additional money are they earning by selling this product? Now, what is their marginal revenue? Well, when I sell one more unit for a perfectly competitive firm, it's just the price I can get away with charging, right? Or that equilibrium price, okay? So if every single quantity I sell, the additional revenue or marginal revenue is just the price I can sell it for, what would the firm's kind of, I guess we could think about demand curve look like? As I sell more, my marginal revenue is always the price of the product, so it will be horizontal, right? So whatever that market equilibrium price is, so here I think I chose $3 for a gallon of gas, we would say the firm's demand, right, or the firm's marginal revenue is just going to be this horizontal line wherever that equilibrium price is. So what happens if, for example, the market demand increases? So if we have a demand increase, well, I have it here, there we go. What's going to happen to the equilibrium price? So this is where this class isn't cumulative, but we're going to use things that we've already talked about in the context now of our complete markets. So if demand for a product increases, what's going to happen to the equilibrium price? So where's my new equilibrium point? At a higher price. So now the firm's marginal revenue, or what we would call the firm's demand curve, right, is going to just be that new equilibrium price, so a little bit higher. Kind of intuitive. If demand for a product increases, that means that firms can get away with charging a higher price. If the price they can charge is higher, is that a good thing or a bad thing for that firm? Good thing, right? Increases the amount of money they're making by every unit they sell, or it's increasing their marginal revenue. So this like firm's demand curve, really it's just the firm's marginal revenue. Okay? Questions on that before we keep moving here? So nothing too crazy yet. So before, I'm going to go a little bit out of order, so I think it makes sense in the context of what we're doing. So I'll leave that up there. There we go. So here. Let's say I've got markers that don't work. Right. So here's kind of the quantity in the market. We're then going to map that out to the quantity that the firm is producing. Right. So here's kind of my price. Right. We're going to map this out into the marginal revenue, or really we're thinking about we've got dollars here on our y-axis, because I'm going to put something other than marginal revenue on it as well here in just a second. Okay. So if I've got my market currently at equilibrium, here's my equilibrium price. We said that's going to be the firm's marginal revenue, right? Whatever that price they can charge is, that's their marginal revenue. I'm just using one to kind of signal this is where we're starting out, right? Scenario one. Now, when firms are making decisions, if I can make more money selling something, that's good, but what do I also need to factor in? Doesn't matter if I can sell something for $4. If it costs me 100, do I want to produce that and sell that good? No, right? So what else? So do we have? We could put on this graph to determine firms' optimal decision making. Right? Oh, sorry. Someone just I'm writing up and looking at you. Mislabeled supply and demand. Thank you. I was like, why am I getting the confused look? Yeah, supply is increasing, demand is decreasing, right? So if my marginal cost, what initially can be happening with my marginal costs? We said they can be, because of gains from specialization, initially as I produce more, a firm's marginal costs are decreasing. Now, over time, because of diminishing returns to labor, we said as we produce more and more as a firm, eventually my marginal costs are going to increase. Well, let's think about how much money am I making from selling each one of these units? If the additional revenue is greater than the additional costs, am I making positive profit there? Yeah, I'm increasing revenues by more than I'm increasing my costs. I kind of have this net positive amount getting added to my profit level. So everywhere here, the marginal revenue is above the marginal cost. Firms will choose to produce up to that point where marginal revenue, as long as it's greater than or equal to. Just like with consumers, at that point, we would say the firm for that quantity is indifferent, right? They're no better off. The profit really earned here would be, well, the additional revenue is the same as the additional cost. So how much do my profits change by? Nothing, right? They're exactly the same. Now, if I would continue to move past that point, what's true about all the units out here? Well, now the additional costs are greater than the additional revenues. So what would I be doing to profit levels if I produce past that point? Yeah, someone's pointing down and decreasing them, right? The additional costs are greater than the additional revenues. So this will be the point where my profits are maximum, right? Producing up to that point where marginal revenue is equal to my marginal cost. Okay. Any questions on that idea before I throw in another wrinkle here? Okay, it's not too bad yet. So what if I have this increase in demand, right? So I guess we'll call this equilibrium price 1, right? Well, my new equilibrium price is going to be higher. Before I get too confused with what's going on in the graphs, if the price of the product I'm selling increases, am I going to want to produce and sell more or less than before? More, right? So what's going to happen if this is the new price I can sell the product for? My marginal revenue at every single unit is now higher, right? So there's going to be some quantities where before I was actually earning negative profits by producing those, right? The additional costs were greater than the additional revenues. Now, after this demand increase with this new higher price, every unit here, the marginal costs are now below my marginal revenues. So there's positive profits to be had, right? The additional revenues are now greater than the additional cost for all of these units. So what does the firm do? It chooses a slightly higher optimal quantity to produce, right? In order to maximize economic profits. Now, once again, don't get too lost in the graphs sometimes. If we can understand that anything that raises the equilibrium price, our firm is going to want to produce more or less. More, right? What if we had something that decreased our marginal revenue? Well, there, if we decrease the marginal revenue, where's our new optimal quantity? It's going to be somewhere lower, right? You can kind of imagine, let's say I had a third marginal revenue, right? After some other shift in this market, this is the new equilibrium price. Well, now for all of these units, the marginal cost is now above the marginal revenue. This would actually be negative profits. So where should the firm stop if this is the equilibrium price or the marginal revenue they face? A lower quantity. But that result, I think, is fairly intuitive. Anything that increases your equilibrium price, it's going to lead to a higher optimal level for the firm to produce. Anything that lowers that equilibrium price, it's going to lead to a lower optimal quantity for that firm to produce. Okay. Also, sorry, looks like it's a little bit angled there. Right? Any questions over this idea before we keep moving here? So I did things a little bit out of order of the slides, but I kind of like to introduce this sometimes first. We'll then take a step back, right? And there's actually another way we can determine where profits are maximized. And maybe it's a little bit clearer initially, but then we'll eventually get to a point where when we make decisions, we're always making decisions based off of marginal changes, right? Consumers, well, the marginal benefit was greater than the marginal cost. That's all we're doing here. It's just marginal benefits are marginal revenues for the firm. Okay? Questions before we kind of jump back into the slides here. Okay. So with this in mind, right, we can also think about what's another way we can calculate profits. So profits we can kind of simply identify kind of have an equation to go with it. We got the slides here. It's just the total revenue minus my total costs, right? That's our most simplistic version of this profit equation. So anytime total revenues are greater than total costs, my profits will be this number is larger than this number. This has to be above or positive profits. Anytime my total revenues are less than total costs, I'll be earning negative profits. And if they're the same, I'll be right at 0. So with that in mind, we can kind of think about, I've really got 3 areas. If total revenues are greater than total costs, I'm earning positive profits. Total revenues less than total costs, I'm earning negative profits. If they're exactly equal, we won't usually say this is where profits are equal to 0. We use a different terminology typically, which is that this is kind of like our break-even point, right? This is where profits we would break even, right? This is where they're equal to 0. Total revenue goes up anymore. Now we've got positive profits. If it goes any lower, we'd have negative. Okay. So nothing, I don't think, too crazy here. Okay. Questions on this before we keep moving? So let's say I gave you a table like this where you've got the different levels of production. Here I did jumps of quantity of 1, so it makes it kind of easy. We got to walk before we can run. I've got the total revenue. So here, if this is gallons of gas, how much must I be selling each gallon of gas for? So if my total revenue is going up by how much each time? 4. So the change in my total revenue divided by a change in quantity, that would just be my marginal revenue. Anytime we want the marginal anything, it's a change in that thing, right? Marginal revenue is the change in total revenue coming from a change in what? Well, it used to be we could think on maybe how much I'm buying, but here for firms, it's how much I'm producing, right? That change in the firm's output. So here, marginal revenue must be 4. The marginal revenue is 4, then the equilibrium price for this product has to be 4 if it's a perfectly competitive market. Now, I then have my total costs here. I could then go through and just simply calculate profits as total revenues minus total costs. Okay. Now, before we get too much further, what would my fixed cost in this model be? 6, right? If I'm producing nothing, the only costs I should have are fixed costs. So we're first going to start out analyzing what do these things look like in the short run. Next class, we'll kind of transition to thinking more about where do we get to in the long run. Right? But for now, we've got fixed costs. We're in the short run. Notice as I start to produce more and more, what's happening to my profit level? It's increasing up to here. And if I continue to produce past a quantity of 10, now what's happening to my profits? Decreasing. So if I'm trying to maximize my economic profits here, what level would I want to choose? That quantity of 10, right? Where is that gap in between the total revenue and the total cost at its largest? Any questions on that? I think I've got a blank slide because I want to draw something out for us here and hopefully connect some of the dots. So let's say, and we'll kind of stray away from this here, but initially, well, should have done lowercase q, but it doesn't matter. Quantity of the firm, right? So we said their marginal revenues are just going to be whatever that equilibrium price is. My marginal costs are going to look something like this. Okay. We can actually directly map, or where did those kind of come from? We can think about, and now I got to make sure I get this. So right here, so I want so if we think about total revenues and my total costs, right? So you can think about here, if I've got total costs, it looks something like this. Oh, no, I'm going to start out here. So here's kind of my total costs, right? If I'm thinking about what represents profits when I'm comparing total costs and total revenues, well, profits are simply the difference between my total revenue and my total cost. So really, if I was looking at a total cost, total revenue curve, I want to find where that gap in between the two, what quantity is that gap at its largest. So initially that gap was relatively small. As I produce more, the difference between total revenue and total cost, that just represents profits. So here is the largest gap. That's where profits will be maximized. And if I continue to produce past that point, what's happening in my profits, or the difference between total revenues and total costs, they're just going down. Well, what is that going to correspond to? The point at which the gap in between my total revenue and my total cost will be at its largest, or where profits will be at their highest amount, that's simply going to be where my marginal revenue is equal to my marginal cost. So if I have my totals, right, like we did up here, I can simply compare and say, well, where is that gap the largest, right? Because the gap between total revenue and total cost, that's just profits. I want to figure out where the profits are at their highest point, where the gap in between total revenue and total cost is at its largest. What we're going to end up seeing is true is the point at which that gap is at its largest will be where the marginal revenue is equal to the marginal cost of that last unit. Okay. Questions, and then you could kind of flip-flop these if you wanted to. We'd already talked about this, so I wanted to kind of map that out in the total revenues. Now notice what's true about my total revenue curve. It's nice and linear, and that's because my change in total revenue is always the same. Right? My marginal revenue, the amount of adding to total revenue, is always the same value, so I have a nice linear total revenue curve. Now my marginal costs are always changing, which is why the slope of my total cost curve, as I produce more, is changing. Right? That's kind of where that comes from. The fact that we have increasing marginal costs, that kind of keeps this total cost curve, that slope always changing. But we have constant marginal revenues, so the slope of my total revenue curve is always the same. Okay. Questions on this before we keep moving here? Okay. So let's go back to those numbers. All right. So we just looked at that. Excuse me. So I've kind of already discussed this a little bit, and it's a little bit of review. But anytime you want the marginal of anything, so a guy think about the marginal utility. It was a change in total utility divided by the change in the number of units we were buying. If I want marginal costs, the change in total costs divided by, well, now how much am I buying? We're talking about firms here, so it's the change in how much they're producing. What is marginal revenue? The change in total revenue divided by the change in the number we're producing. So we said we can make these optimal decisions, not just looking at kind of the comparison of total revenue to total cost, but also where does marginal revenue equal marginal cost? Okay. So the optimal rule, already introduced this, the quantity that is going to maximize profits, the quantity that is going to lead us to choosing the quantity that has the highest profit level here, or the highest gap in between total revenues and total costs, is going to be the quantity where marginal revenue is equal to marginal cost, or as close as we can get to it. All right, so let's think about in a slightly different way. Why is that the case? Right? Now, I'm not expecting you, I guess we could kind of break this down into a little more complicated math, but the idea is if I'm taking a change in respect to so instead of marginal revenues, marginal costs, let's say I want to do my marginal profits. So if I take a derivative of something in respect to what's changing, so derivative of profits in respect to quantity, well, we know we can rewrite profits as total revenue minus total costs. So that would just be the change in total revenues from a change in quantity minus the change in total costs from a change in quantity. So law of derivatives there. Well, what does this represent? My marginal revenue minus my marginal cost. So anytime my marginal revenue is above my marginal cost, what is the change in my profit level? Marginal revenue is greater than marginal cost here. The change in my profits from producing more would be positive. Okay, change in profits that are positive are great for me as a firm. Well, what happens as soon as marginal revenue is below marginal cost? Now, if I produce more, the change in my profits would be negative. Now I'm just eating into my profits. Why would I want to produce more? So this is the idea of why we go up to that point where they're exactly equal to each other. So here's kind of our rules, right? As long as marginal revenue is above marginal cost, We want to increase production because we're increasing profits. Anytime marginal revenue is below marginal cost, we actually want to decrease production. Because if we continue to increase production, we're just decreasing our profits. And then if they're equal, that's going to be the point at which profits are maximized. Okay. Any questions on this before we keep going here? Okay. So let's kind of put this all together, right? So we already knew from these numbers, looking at total revenue and total cost, just taking the difference between the two told me my profits. So we already knew profits were maximized at this quantity of 10. Now, if I wanted to find my marginal revenue, that would just be a change in the total revenue divided by a change in quantity. Well, every single one of these, as I increase the output by 1 unit, what's the change in my total revenue? 4, or the equilibrium price of the good. So here I have gallons of gas. You think about $4 a gallon, just have a nice, easy number to deal with. I've got this constant marginal revenue for every single unit. Now, my marginal costs, what portion, to what quantity do I have gains from specialization? Still have gains from specialization? No, right? Where do they stop? 6, right? As long as my marginal costs are decreasing, I know I must be having gains from specialization. Now, after that quantity of 6, what's going to happen? Diminishing returns are going to take over. Now my marginal costs are starting to increase. How did I find these marginal cost values? It was just a change in my total cost. So going from 1 to 2 units, the change in my total cost was 3 divided by the change in quantity of 1 gave me that marginal cost of 3. Change going from the second to the third unit, change in my total cost was what? 2 point, no, hold on. Where am I at? There we are. So 2.4 divided by the change in quantity of 1 gave me that marginal cost of 2.4. Right? So that's where these marginal revenue, marginal costs are coming from. Right? Simply looking at the change in either total revenues or total costs divided by the change in quantity. So what should be true? We know the quantity of 10 maximized profits. What should be true about every quantity below that is that my marginal revenue is greater than my marginal cost, because as long as that was true, we said profits would be increasing. So as long as my marginal revenue is above my marginal cost, what was happening to profits? Oh yeah, they were increasing. Now at that 10th unit, I'm still increasing my profits, right? The marginal revenue is still just barely above marginal costs. So I am still increasing my profits a little. If I were to continue past that point, my marginal revenue is now below my marginal cost. So what's happening to my profit level? It's decreasing. It's not that my profits will all of a sudden be negative, right? They're still positive there. I guess I could make a mistake and still earn some money there, right? But they wouldn't be maximized, right? I'll produce up to the point as long as marginal revenue is greater than or equal to my marginal cost, and that will be the point at which profit levels are maximized. Okay? So it doesn't matter if we use the difference between total revenue and total costs, or we simply look to see as long as the marginal revenue is above our marginal cost, both of them would lead us to the same optimal quantity here of 10. Okay. Oops. Yeah, let me move this out of the way. And I don't see if we can get this out of there. We go. Okay. Any questions on this before we keep moving? Okay. So if I'm thinking about something like this, kind of jumped the gun earlier, but if I've got my marginal revenue, my marginal cost curves, the optimal quantity is simply where they cross, right? Where are they equal? So let's think about if I had something like an increase in demand. We did this earlier, but what does that do to my equilibrium price? It increases it. So where is my new optimal quantity? A little bit higher. Now, just to be kind of complete here, because I think everything in the slides is all about demand changes. We could have, so here's the quantity of the firm, here's market quantity, here's the price. So I got supply, demand, and I've got my equilibrium price here. Thank you. There we go. So I've got my market supply, my market demand, and the initial equilibrium price. What is my firm's marginal revenue going to be? Whatever that equilibrium price is. I then kind of think about, okay, I've got my marginal cost curve in here. Now, let's say that there's something that shifts supply. So if there's something that shifts supply, so let's say the firm's costs actually stay the same. So it gets kind of weird because supply, we said, represented what? The firm's marginal cost, but it's really every firm in that industry. So here we're looking at just one firm. Their marginal cost might not change, but if we're thinking about if more firms enter this market, what's going to happen to supply? Supply is going to increase. What's that going to do to our equilibrium price? Decrease it. So it doesn't just have to be demand shifts. We could have supply shifts in the market as well that are going to change the marginal revenue of the firm. So before, the optimal profit maximizing quantity for the firm was right here. Once that equilibrium price goes down, once again, let's just think about the intuition, not too lost in the graphs. If the price I can now charge for this product is lower, my firm's marginal costs haven't changed at all. What's going to be true? Do I want to produce more or less? Less, right? So my new optimal quantity, or the new quantity where the marginal cost is equal to the marginal revenue, after that supply increase in the market, is actually going to be a little bit lower. This gets to be kind of weird. So, because like in the market, what happened to my equilibrium quantity in the market? It actually went up. So how is that the case? If firms are producing less, but in the market, I see that the total market quantity is higher, what must be true? There's more firms, right? So that'd be the idea. If, I had 2 firms producing 10 before, I had a total of 20. If I now have 5 firms producing 5, well, every firm that existed before cut their production in half, but 5 times 5, my new market quantity would be 25. All right, so we can still see that market quantity increase, even if the quantity that each firm produces, and this is the existing firms, goes down. Questions? Yeah. Yep, so this would be kind of our market supply, our market demand. Here's going to be our firm. Yep. Any other questions on that before we keep moving? Okay. Yeah, we'll hold up. I think that's good for now. So now we'll get a little bit tricky. Okay. And actually here, I can go through these since we've got multiple screens here, just in case people are still writing this down. All right. So the next thing is something I'm not going to expect you to ever reproduce, but I'm showing you where it comes from, right? Because I hate just telling people this is the way it is without actually giving you a reason why. So let's say we started out with this profit equation that was pretty basic, which was just total revenues minus total costs. Okay? I'm going to rewrite total revenue. Well, how much total revenue am I earning? However many units I'm selling, every unit I'm selling for the same price. So my total revenue is just the equilibrium price times the quantity I'm selling, right? Price times quantity, just rewriting that. Now I did a little tricky thing here. If I multiply the total cost by quantity divided by quantity, did I change anything? No, I multiplied by 1. But if I think about now, I'm going to rearrange this because order of operations doesn't matter if I divide or multiply first. If I kind of take this quantity, take total cost divided by quantity, and then multiply it by the numerator over here, I haven't changed this equation at all. But what is in parentheses now? Total cost divided by quantity is my average total costs. So when we sell the same product for the same price, you can kind of think about that equilibrium price is really like my per unit revenues. It's how much revenue I was earning on every unit I was selling. My average total costs, that's going to be my per unit cost. So if I rearrange this equation a little bit, I'm multiplying both things by quantity here. sorry, we said this already. This was average total cost. I then kind of moved that quantity out. Notice another form of the profit equation is taking the quantity I'm selling, the number of units I'm selling, multiplying it by the difference between my per unit revenues, that was just the equilibrium price, and my per unit costs. Essentially, what's in parentheses there would represent my per unit what? Profits, right? Price is like my per unit revenues. Average total cost is my per unit costs. So this profit equation is saying, take my per unit costs, multiply it, sorry, take my per unit profits, multiply it by the quantity I'm producing, that would give me my total profits. So we started out with this very basic equation. We've now got it worked down to something a little bit different. Now, this is going to line up a little bit better with a lot of the graphs that we look at, also a lot of the data that firms are going to report, right? We can get a lot better of idea about kind of per unit costs. Also, we can go out, gather information on what the price of a homogeneous product are and the number of units of the quantity or a firm is selling, right? So this is going to be another form of the profit equation we can use, okay? Questions on anything there before we keep moving? Okay. So if I wanted to calculate profits and I didn't have total revenues and total costs, well, what's the optimal quantity here? We said as long as that marginal revenue is above our marginal costs. So we went up to that quantity of 10, right? So at this price of $4, the optimal output is 10. What are my total profits? Well, my price that I'm selling the good for is $4. If I were to calculate my average total cost of that quantity, it's $3.05. So my per unit profits, the difference between the price and the average total cost would be 95 cents a unit. I'm selling 10 units, so my total profits would be 95 cents times 10, or, whoops. There we go. My arrow was a little bit too big there, right? Would be kind of that profit that we calculated the same way before. We get the same values if we use total revenues and total costs. Doesn't matter which equation we use, we should end up calculating the exact same value for profits. Questions on this before we keep moving forward? So let's get a kind of visual of this here. So I've got one here, we'll kind of work through, and I think I'll build this out. I think it makes more sense. So let's say I've got my average total cost curve and my marginal costs, right? So where does that marginal cost curve hit my average total cost curve? At its, so we said this in module 9, as long as the marginal cost is below the average, my new average has to be smaller, right? So what is this point of my average total cost curve where marginal cost intersects it? It's going to be at its minimum point. So if I ever have a price, so we'll start out with blue here. So let's say I have this equilibrium price, which is the marginal revenue of this firm. Where's the optimal quantity? Well, where does marginal revenue equal my marginal cost? Looks like it's at a quantity out here. So we'll kind of say this is like our initial point. Okay. Everybody with me up to that point? What would my profits be depicted in this graph? Well, I know that my profit equation is the quantity that the firm sells times the difference between the price they're charging and their average total costs. So at this quantity, what's the price? Well, we've got that already up here. What's my average total cost? So what would represent the quantity the firm is choosing? It would be the kind of width of this rectangle. What's the height of this rectangle? It's the difference between the price and average total cost. So what would this rectangle represent? My profits. Right? It's going to be the difference between my price and my average total cost multiplied by the quantity the firm is choosing to produce. So here I've got positive economic profits anytime that marginal revenue curve is above what? That minimum point of my average total cost curve. So as long as you have a price that's above that minimum point in your average total cost curve, you know that profits here are going to be positive, right? Any questions on this idea? Now I've got something in the slides here, so this will get a little bit more complicated if you want like the basic. All right. And I'm just kind of putting the values there that we had from that table. Now, what happens if the price is relatively high? Well, what might firms do? If firms are currently earning positive profits and I've got a bunch of money to start a new business, do I want to join this market or not? Well, if there's positive profits to be had, yeah, I want to get a slice of that pie, right? What happens as firms enter a market? Supply will increase. What did we say that does to the equilibrium price? Lowers it. So as firms enter, what's going to happen? That price is going to get lower and lower until we get to this point. Once that kind of new equilibrium price, call it not squared, but it's the second price we're thinking of here. Once that marginal revenue hits the minimum point in my average total cost curve, now profits are going to be what? Well, price is exactly equal to my average total cost, so profits would be 0, right? So anytime I've got positive profits, we might see that firms are going to enter this market until those profits get driven down to 0. Now there's no incentive for any firm to join this market, right? They're indifferent. Right? Any questions on that idea before we keep moving? Okay. Now, what if instead, and you can probably already guess what's going to happen here. Let's say I had, I'm going to try to draw them pretty similar. Average total cost, marginal cost that hits it at its minimum point. So let's say now I've got, oh, what do I want? Let's say I've got a price that's down here. So here's my equilibrium price, which is the marginal revenue this firm is going to face. Where's the optimal quantity for this firm to produce? If they're trying to maximize profits, it's going to be where marginal revenue is equal to marginal costs. So here, that optimal quantity is going to be down here. What's true about profits here? Well, once again, profits are the quantity that the firm is selling times the difference between price and average total cost. The price here is below my average total cost. So whatever my average total cost value is here, now this is kind of assuming the firm is trying to still maximize profits. In this scenario, price is below average total cost, so my profits will still be represented by this rectangle, the difference between price and average total cost times the quantity the firm chooses. But now these profits will be negative, right? So now I've got negative profits. Now, it still might be that operating that point still maximizes profits, okay? So even if we have negative profits, why might that still be better than just simply producing nothing? If I produce nothing, what do I have to pay? My huge fixed costs. A lot of companies that we see out there, we're talking about fixed costs in the millions, right? And so, yeah, maybe I'm earning negative profits, but it's a much smaller negative value than if I simply shut down. So with positive profits, it's not that interesting. We know the firm wants to stay open, right? We have 0 profits, they're kind of indifferent, right? They're no better off if they stay open or kind of continue to operate at the same point or not. Anytime we have negative profits, we now have this more interesting decision, which is, okay, we can still identify where that optimal quantity is, but now we have a second decision. Whatever profits are here, are those a smaller negative value than simply shutting down? So when we have negative profits, we then have to make the next decision, which is, okay, I know that I'm maximizing profits if I stay open at this quantity, but it could be better if I simply shut down. Okay. So that's the next thing that we're going to kind of talk about. Okay. So I've got my positive profits here. We just went through. This switches over for me. There we go. We just said if we anytime we have a marginal revenue below the minimum point in our average total cost, well, there we still calculate profits the same way, but price is below average total cost, so these profits would be negative, right? And I could go back to that table. Excuse me. If the price was, say, 275. So if my price was 275, all of these would be 275. Where's the last quantity that's greater than the marginal cost? It would actually be here at a quantity of 8. The average total cost would be $97.5. So I would just be plugging those values in. I think I kind of rounded it a little bit there, right? And that's how I would calculate my negative profits. Now, like a problem I might give you, I give you like a grid line here, so it's a little bit easier to identify exactly, what these values are. It's kind of hard to exactly see here. Okay. So we already talked about the break-even price. It's not that interesting. That's just going to be that minimum point of our average total cost. We know if the marginal revenue or the equivalent price ever goes above that point, positive profits. If it ever goes below that point, we're going to end up with negative profits. Okay. Let me think what I want to do here based off of how much time we have left. Well, I want to kind of play around with this table. So here was that kind of module 10 table that I had. So let's say, where do I have it? Kind of got Excel set up. So let's say this is my equilibrium price. And we'll go back to that example that we had of $4, right? So we kind of said here, if the price was $4, what did that lead to? The highest profit level was at that quantity of 10. This is the value that I was showing you in the slides, right? Well, what's the minimum point of my average total cost curve here? So if I'm looking here, what's the lowest possible point? $2.96. So anytime the price is above that, I should have what kind of profits? Positive. Anytime it's below, the optimal quantity would result in negative profits. We can kind of prove this to ourselves using this very simple data set. So even if it was like $3.20, that's still above that minimum point. So we now kind of look to see where our profit level is maximized. Well, now it's not at a quantity of 10, it's at a quantity of 9. That would be the last, where's my marginal cost? Here it is. That would be kind of the last quantity where marginal costs are still below that marginal revenue of $3.20. So I could still end up with positive profits at that profit maximizing quantity. Now the profit maximizing quantity is no longer 10, it's now 9, right? So that point would change, but I still have positive profits. Well, what if I instead had a price of $2.50? Well, that's going to be below that minimum point in my average total cost curve. So now at the optimal quantity, or where profits are maximized, I know my profits are going to be negative. Right? So if I hit enter here, it gets kind of tricky because, well, now in Excel, if you don't know, these parentheses mean a negative value. So everything's negative. So if I'm maximizing profits and everything's negative, I actually want the smallest in magnitude value. So there, that would be what? Right here at this quantity of 10 still, I've kind of minimized my losses. So another way of saying I'm maximizing profits, if all my profits are negative, I'm minimizing my losses. But you got to see here, anytime that price falls below the minimum average total cost, the point at where I'm maximizing profits, I'm actually going to be minimizing losses if that price is below the average minimum point of the average total cost curve. Now, where should my profits be zero? Well, we said the minimum point my average total cost was $2.96. So if I change this, $2.96. Okay, well, because we have kind of jumps here of 1, it's not truly continuous. It's not exactly 0, but it's pretty close, right? Now, if we had much more kind of continuous, like let's say I could choose quantities in between 8 and 9 or in between 9 and 10, there we would kind of end up finding there's a very precise point. Maybe it's like $2.96 and, or 96.3 0.312 cents, right? It's going to be some other, because we're keeping everything in the second decimal here, we might not end up with exactly zero, right? But we're going to be very, very close to it, right? Whatever that minimum point in our average total cost curve is at, that's going to be our break-even point. The price ever falls below that, even if it falls to $2.95. Oops, well, that would not help. There we go. $2.95. Notice, oh yeah, now the lowest profit is negative, right? That was my break-even price. If it ever falls below 296, now my profit's going to be negative. So I'm not going to like make you use an Excel file like this. It's not kind of part of this course, although I could argue we should probably do a little bit more data work. I mean, you guys are in Kelly, so you're going to end up using tons of data throughout the next 4 years, hopefully. Especially if you take 370, you'll really dive into this. But that's kind of just a quick way we can kind of play around with that equilibrium price and kind of see these things we talked about hold true. Right? Or we kind of have these visuals when the price is above the minimum point of average total cost, positive profits. When the price is below the minimum point, negative. And when it's exactly equal, we had zero profits. Okay. All right. Any questions before we keep moving here? Okay. So I'm going to introduce the next topic, and then we'll have a little bit of time. Might go through a couple problems. So I just want to introduce this idea, but we'll really kind of hammer it home next class. So I already alluded to this, but if in the short run, sometimes my profits will be negative, the next decision I have to make is, okay, are those negative profits, are they smaller than if I completely just shut down? Because if shutting down actually leads to a smaller loss, that's what I should be choosing to do. So examples of this, believe it or not, there are a couple of ski places in Indiana. They're not open in July, right? Why? Because they know if they stay open, they're going to have to pay all these costs to stay open, and no one, literally the revenue they're going to earn is zero. No one's going to go in July, right? However, they don't want to completely shut down because they know if I can kind of earn some negative profits in the summer, the profits in the winter might make up for that, right? So in the short run, depending on my fixed costs, it might actually make sense for me to shut down temporarily so that when demand is higher down the road, I can enjoy these positive economic profits. So you'll see, ski resorts in the summer do this. Really, a lot of things, like the examples that are easiest are things that are related to like cyclical changes, but it doesn't have to be summer or winter. In fact, the exact opposite. I grew up down here in Michigan, and like all the towns along the lake, it's probably true if you go up and down like the east and west coast too. A lot of them are these small towns that more than half the businesses are not open in the winter because nobody comes there in the winter. Everyone wants to go there to go to the beach, right? So you'll see a bunch of these businesses, even restaurants, right? In the short run, they'll make the decision to shut down in the winter, but stay open when demand is higher in the summer. So firms do this. Like we see firms make this decision to shut down in the short run, but they don't like completely shut down, right? They don't leave the industry. Okay. So what is their shutdown rule going to be? So if price is below average total cost, we said we know profits are negative, right? So if we continue to operate, here was going to be our profit equation. Right? Well, I'm going to break this down. We know our average total costs are going to be the sum of our average variable and our average fixed. So I'm just going to rewrite my total costs to be the sum of those two things, right? So my profit equation, if I'm subtracting my average total, same as subtracting my average variable and my average fixed. Okay? If I shut down here, what's going to be my profits? Well, what would my variable costs become if I shut down? Zero. What's the amount of money I'm earning if I shut down? Zero. However, I'm not going to have my fixed costs. That doesn't depend on quantity. So here, if I shut down, I can kind of think about what am I going to have? Well, producing zero, I end up with total variable costs that are zero, but I still have my fixed costs. So if I shut down, my profits, I automatically know are just going to be negative whatever my fixed costs are. Now, if I stay open, when would I be having lower losses? Anytime this value is positive. So if I stay open, what has to be true in order for staying open to minimize my losses? It would have to be that the price is greater than my average variable cost. That's the only way the second component of my profit equation would be positive. Now, if the price falls below average variable, well, then by staying open, my profits aren't just negative fixed costs, they're my negative fixed costs plus some additional negative value. So our shutdown rule, our shutdown rule is simply going to be anytime that price falls below my average variable cost, I'd actually be minimizing my losses by just shutting down. Now, anytime price is above average variable, but below average total, we know profits will be negative, but by staying open, I'm going to be minimizing my losses, or my losses of staying open or operating are going to be greater than the losses if I simply shut down. Okay. So the shutdown rule we're going to start to evaluate is once the price is below average total, we know profits are negative. The next thing we have to check, if the price is above average variable, we should stay open and operating, right? Minimizing losses. If the price falls below the average variable, we should just shut down to minimize losses. So we'll kind of revisit this and start with this next class. I think I've got kind of these different ranges broke down here. So we'll revisit this. We'll kind of then move to thinking about long versus short run. Excuse me. But for now, I just want to kind of leave us off with this idea that we can have positive profits, negative profits, and profits are negative. We then have to think about how we're going to shut down. And this is just in the short run. Once we move to the long run, there we'll kind of see there's only really one decision to be had. So if price is above my average variable costs, or this difference is positive, then my profits, I'm adding a positive amount. So as long as price is above average variable, the losses from staying open are actually going to be, oh wait, no, that's not well, you're right. This should be the reverse, right? My losses from staying operating are actually going to be lower than the losses from shutting down. Right? Now it gets kind of tricky if we're using net or greater than less than signs. Because it's a smaller negative value, it's technically less, like the loss is less because it's a smaller negative value. But if we're referencing them as losses, that's the way to think about it. As long as price is above average variable, our losses from staying open and operating will be lower than the losses if we just shut down. But as soon as that price falls below average variable, there we should just kind of shut down completely. Okay. All right. So we'll revisit this next class. We'll dive deeper into it. But before that, within class here, I want to kind of work through some of these. Okay? So let's say I had a question like this. Okay? And I'm thinking about, hopefully these should be relatively easy. If I'm thinking about my break-even price here, what is the break-even price going to be equal to? What point on my average total cost curve? The highest possible point? No, the minimum, right? So if I'm thinking about where's my break-even price, well, I don't know which of these are my average total cost curve. I've got three costs, but the fact that this blue line is intersecting these two at their minimum point, what did we say? The marginal cost is intersecting my average total at its minimum point. What will also end up being true, we said for module 9, is it also hits the average variable cost at its minimum point. Okay? So anytime we kind of have these curves and we're not sure which is, well, the one that's intersecting these two at its minimum point, this blue line would be my marginal cost. Now, how do I know my black curve is average total and my green curve isn't? If I'm thinking about average total, average variable costs, average total always has to be greater, right? It includes the average variable plus the average fixed. So that minimum point of my average total cost curve looks like it's going to be right here at what? 425 and a quantity of 350. So 425 and kind of 425 was the price, 350 was the quantity, right? So that would be kind of our break even price of $425 and quantity of 350 units. Okay. Questions on that? So we want to have this idea of the break-even price locked in, especially once we start talking about shutdown prices next class. Okay. If I then go thinking about, so this one, just try to kind of make a point. Let's say my marginal revenue was $125. So if my marginal revenue is $125, what must be true about the price of the good? Price of the good would also be 125, right? The equilibrium price of this product was the firm's marginal revenue. So if I look here at 125, it hits my marginal cost curve at 2 points. Now, I'm never going to try to trick you. This can be the case if we're ever operating in a portion where, well, it doesn't matter which of these quantities I think about where marginal cost hits marginal revenue. What's true about the marginal revenue or the price relative to my average variable cost at both those points? It's less. So we said anytime the price falls below average variable, it's actually more profitable if I simply shut down, right? So if I'm thinking about the optimal quantity at that price of 125, I should just be shutting down, right? Producing absolutely nothing, right? That's how I can minimize my losses. Now, if the price ever goes above what? 175, well, now I'm in this range where my price is above average variable. Now I should stay open because that would minimize my loss. But anytime that price falls below the average variable cost or below that minimum point on our average variable cost curve, any price in this range, we know we should simply just shut down, producing a quantity of 0. Okay. Questions on that? Okay with that? Okay. And then one more. So what would the level of profits be if I had an equilibrium price of 350? So if I have this equilibrium price of 350, that's going to be my marginal revenue. Where would that hit my marginal cost? Looks like it's at a quantity of 325 units. But at that point, what's true about the price of 350 relative to my average total cost? So my profits will be negative, right? If my price is below average total, if I go to calculate these, now I'll still calculate profits the same way. It's the quantity I'm selling times the difference between price and average total cost. So here, my price is 350. Quantity we said was 325. And at that point, my average total cost looks like they're 425. So there, the difference between average total cost and price would be $75, 425 minus 350, multiplied by that quantity, okay, of 320, all right, of 325, right? Now, we only have 2 negative answers here, so can't do that math that easily in my head, but if I take that difference between price and average total cost, which was 75, multiply that by the quantity of 325, we want to limit guess, you get that negative 224,000. Excuse me. So you can check me if someone wants and let me know if I'm wrong, but I'm pretty sure that's what it is, right? So 75 times 325, and obviously negative 75 since the average total cost is above price. So before you go, I have an important thing to say before you leave. So I'll get these questions. They should be set to release on Canvas at 4:30. Kind of get on. Make sure you get those done before we meet in class on Thursday. Keep an eye on Canvas announcements. I already mentioned my office hours at the beginning of class. No, I'm going to be on call tomorrow for something I have to leave the university for. I should be getting a 30-minute call ahead of time. I expect it'll be in the morning, so I don't think my office hours will have to change, but they might. Okay, so keep an eye out on Canvas. If they do, I plan to have office hours on Friday. So I plan to have office hours on Friday. If for whatever reason, I cannot be here tomorrow afternoon. If you want to review your exam, that would be a good time to do it, is to stop by during office hours. Like I said, keep an eye though. If I'm not going to be there tomorrow, I'm going to have to reschedule any of those for you to stop by on Friday. Okay. If you want to meet virtually tomorrow, I should be able to still meet virtually all afternoon, kind of in a typical time frame. Also, next Thursday's class, right? It is likely that there will be a video recording that replaces class. Okay. Keep an eye on Canvas. I will give you up-to-date information as soon as I know it. I should have a better idea Monday, unless something happens before then, but my wife's likely going to be induced next Thursday. So I'll have a recording up there to replace class. I'm hoping I should be back then the following week. If something changes, once again, I'll use Canvas to kind of update you, let you know. But that's likely what's going to be the schedule for the next week and a half. Okay? All right. See you guys on Thursday.